Have you ever tried to imagine nothing? Not just emptiness, but a true void where even space and time don't exist? It's a real head-scratcher, but it's also where our universe might have come from. We usually think of nothing as just the absence of everything. But what if nothing itself has qualities we're only just starting to understand? What if the very fabric of reality is built on something way stranger than we ever thought? Modern physics shows us a world where emptiness is just an illusion. Even in the vacuum of space, quantum fields are buzzing with activity, a constant dance of energy and potential. These fields are the bedrock of our universe, giving rise to the particles and forces we see. So when we talk about the universe coming from nothing, we're not talking about absolute emptiness. We're talking about a state of existence beyond our everyday experience, a place where the laws of physics as we know them might have been totally different. Picture a massive, invisible ocean stretching across the cosmos. You can't see it, touch it, or smell it, but it's always there, a constant presence underlying everything. This is the realm of quantum fields. These fields aren't made of matter, but they're just as real as the ground under your feet. Think of them like a giant cosmic drumhead. When you hit a drum, it vibrates, making sound waves. In the same way, when energy interacts with quantum fields, it creates ripples. And these ripples are what we see as particles. These particles aren't permanent, though. They pop in and out of existence, constantly created and destroyed in a flashing dance of energy. It's a bizarre, counterintuitive world, but it's the reality revealed by our most advanced physics. The existence of quantum fields means that true nothing is probably impossible. Even without matter and energy, these fields would still be there. A constant hum of potential just waiting to erupt into something more. Right, let's rewind the cosmic clock. We're going billions of years back in time, past the birth of stars and galaxies, to a time when the universe was a scorching hot, dense soup of energy. This is the Big Bang, the event that kicked off our universe as we know it. The Big Bang theory describes how our universe expanded from an extremely hot and dense state. It's like blowing up a balloon. As you put more air in, the surface expands. In the same way, our universe has been expanding and cooling for billions of years, but here's the biggie. What caused the Big Bang? What was happening before the universe started expanding so rapidly? These questions have stumped scientists for ages, and the answers are still a mystery. The Big Bang theory is really good at explaining lots of things we see in the universe, but it doesn't tell us everything. It's like having the middle chapters of a book. We can work out part of the story, but the beginning is still missing. Even though the Big Bang theory is pretty spot on, there are a few cosmic puzzles it can't quite explain. Imagine finding a perfectly smooth, evenly cooked pizza straight out of a stinking hot oven. That's not how ovens usually work, is it? You'd reckon there'd be some differences in temperature and how it's cooked. It's the same with the early universe. According to the standard Big Bang model, there should have been some irregularities. But when we look out at the cosmos, we see remarkable uniformity in the cosmic microwave background radiation, the afterglow of the Big Bang. This uniformity is a real head-scratcher. Parts of the early universe that were miles apart shouldn't have had time to reach the same temperature, but they did. It's like everyone in the world waking up to the exact same temperature in their homes, even though they live in totally different climates. This is just one of the things that makes us think something more might have happened in the universe's earliest moments. It's as if the universe started with a very specific set of initial conditions, almost like someone carefully set everything up just right. Inflation to the rescue, a universe blown up. To figure out these puzzles, cosmologists added a new chapter to the Big Bang story, inflation. Imagine a universe that, for a split second after the Big Bang, expanded faster than the speed of light. This period of super-fast expansion, called inflation, could explain the universe's uniformity and other things we couldn't work out before. Think of a tiny crumpled-up piece of paper. If you were to stretch it out really quickly, the wrinkles would disappear. In the same way, inflation could have stretched out any initial irregularities in the early universe, leading to the smooth cosmic background we see today. Inflation is a really handy idea because it solves a bunch of cosmic mysteries all at once. It's like finding one key that unlocks heaps of doors in a spooky old mansion. But wait, there's more. Inflation also gives us some mind-blowing possibilities, like the idea of a multiverse, where our universe is just one of many bubbles in a massive cosmic foam. A multiverse of possibilities? If inflation is right, it might be happening right now in other parts of the cosmos. Picture a pot of boiling water. Bubbles pop up, get bigger, and sometimes join together. In the same way, inflation suggests that our universe might just be one bubble in a massive multiverse. Each bubble universe could have its own set of physical laws and constants. Some might be good for life like ours, while others might be strange and dangerous places. It's a mind-boggling concept that's hard to even imagine. The idea of a multiverse is still a bit out there, but it makes sense according to some of our best theories about the early universe. If it's true, it would completely change how we see our place in the cosmos. We wouldn't just be a tiny part of one universe, but residents of one island of reality among countless others, each with its own unique story. The curious case of virtual particles. Let's head back to the quantum realm where things get even weirder. In the subatomic world, particles don't always play by the rules we're used to. They can just pop into existence, borrow some energy for a split second, and then vanish again. These ghostly things are called virtual particles. Imagine a bank account where you could borrow as much money as you wanted, as long as you paid it back straight away. Virtual particles work in a similar way, constantly borrowing energy from the vacuum of space and then giving it back in a flash. These particles might seem like something physicists just made up, but they have real measurable effects. They affect how atoms behave and contribute to the energy of the vacuum itself. Virtual particles just go to show how strange the quantum world is, where emptiness is an illusion and even nothing is buzzing with activity. Before the bang, a quantum fluctuation? So how does all this link back to the big question of what was happening before the Big Bang? Some physicists reckon our universe might have come from a quantum fluctuation, a random blip in the quantum vacuum. Picture a perfectly still pond. Then, out of nowhere, a tiny ripple appears on the surface. That's kind of like a quantum fluctuation. These fluctuations are just a natural part of how unpredictable the quantum world is. If our universe did come from one of these fluctuations, it would mean our existence is basically down to chance, a random event in a massive sea of possibilities. It's still a pretty out there idea, but it's a tantalizing possibility that gets you thinking. If it's true, it would mean our universe is just one of countless others, each one a unique experiment in a giant cosmic laboratory. The mystery endures unanswered questions. Even with all our advancements in cosmology, the ultimate origin of the universe is still one of the biggest mysteries in science. We've come a long way in understanding the Big Bang and what happened afterwards, but the very beginning is still a mystery. It's like being at the edge of a massive, unexplored wilderness. We can kind of see the landscape, but the details are hidden in the mist. We can guess what's out there, but we need more info to solve the puzzle. The good news is that scientists are always coming up with new tools and techniques to investigate the universe's earliest moments. From powerful telescopes looking back to the dawn of time to sophisticated computer simulations recreating the Big Bang, we're getting closer to the truth. Trying to understand our cosmic origins is like going on a journey into the unknown. It shows how curious we are and how much we want to learn. Section 10. Our quest for cosmic understanding. Searching for our cosmic origins is more than just something scientists do. It's a deeply human quest, driven by our curiosity about where we came from and how we fit into the grand scheme of things. Throughout history, humans have looked up at the starry sky and wondered about their place in the universe. We've come up with myths and legends, built elaborate cosmologies, and developed sophisticated scientific theories, all trying to make sense of our existence. The universe doesn't give up its secrets easily, but that just makes the chase more exciting. Every new discovery helps us understand our place in the cosmos and makes us appreciate the beauty and mystery of the universe we call home even more. Keep looking up. The universe is full of surprises, so next time you're looking up at the night sky, remember you're looking at what's left of a cosmic explosion that happened billions of years ago. An event that might have been caused by a random quantum fluctuation in a sea of possibilities. The universe is full of amazing things, and we're only just starting to understand its mysteries. Keep asking questions, keep exploring, and never lose that sense of wonder. The universe is a massive and strange place, and the more we learn about it, the more we realize how much more there is to discover. So, keep looking up. Who knows what amazing things you might find.